On behalf of the distinguished panelists here and myself, I think it's an honor to be part of your first space-related Venture Lab event. So thank you once again for having us. I thought I'd take a few minutes before we launch into the panel and our first speaker to talk about what is space. So right now, I think it's very fitting we're doing this event because we're basically beginning or entering a new paradigm in the space industry. Things are changing. Traditional space, the rules, the definition, the concepts of traditional space are in drastic flux. So right at the beginning of an inflection point of what we call space. In fact, I would actually say this new era we're beginning upon is best defined through the term new space. So when a lot of you think about, when a few of you think about what space is, and most people in this room, others outside this room, when you think about what space is, usually it conjures up images like this. This was the longest non-tethered spacewalk done in the mid-'80s. Images like this, the Hubble Space Telescope, the Space Shuttle, Buzz Aldrin standing on the moon in 1969. Images like this, rockets. Images like this, Apollo lander on the moon. The Earthrise from the far side of the moon. The International Space Station. But I challenge every one of you in the room today to kind of expand your definition of what space is, expand the scope of what space is. I think very soon you'll be defining space through images like this. GPS applications. Images like this. Satellite TV applications. Satellite radio applications. Satellite imagery applications. Geographic information systems, the data underlying underneath them. Mining, eventually one day. Platinum, nickel, tin. Biotechnology application. This is actually an image of a protein crystal developed in space. Human proteins fold, certain human proteins fold at a much higher rate, better quality, and better quantity in space versus here on Earth. They become the precursor to several drug development processes. So pharmaceuticals is another application as well. So what I'm challenging all of you to do is kind of give up your traditional notions of what space is and think outside the box to a lot of these applications I just showed you. This is just a minimal list, a subset of the longer list of applications that space can drive. So with that beginning, here's some themes that we're going to touch upon during the panel today. And my distinguished panelists are going to help me talk through these areas. Point number one, or theme number one, is that space necessarily is not a destination. It's not necessarily a place to go just because you want to go there. It is in some cases, but not all. It's a disruptive way of doing business. It enables the enhancement of several business verticals. So the analogy I like to use here is the internet. So the internet in and of itself, it enhances a lot of existing business areas. It transforms the way you buy books. It completely revolutionizes the way that you book airline tickets or you talk to friends, communicate with friends. The space, in the same way, is kind of an enhancer to existing business verticals. It makes them faster, cheaper, and better. Definitely in the long term. Theme number two is space is not as different as you may think. There are actually very strong similarities between the space industry and the high-tech / internet industry of the Silicon Valley. So we'll touch upon a few of those themes throughout the talk today. And the last theme that we'll try to center around is we think, at the beginning of an inflection point, an uptick in the space industry. Numerous factors, NASA's transition being one of them, are kind of fueling this change. The first time this has occurred in the 50-plus years of what we call the space industry. So we're kind of living in the right moment for this. So let's start with theme number one. Space is just not a destination only. It actually enables numerous applications, some that you may think are outside the box. So very simplistically, this is kind of Space 101 on one slide, is divided into two buckets: infrastructure, space companies, and application, space companies. Very, very similar to the definition of what you would think a traditional Silicon Valley infrastructure company and application company would be. So the infrastructure companies build the stuff that get you to space, whether it's people, whether it's cargo, whether it's other types of hardware. In-space hardware is kind of like satellite systems, the stuff that are in space. Everything else below that are kind of the applications or companies that derive value from the infrastructure above and make a buck. So things range from healthcare. We talked about biotechnology type applications, medical device research, Earth observation. Satellite imagery is well over $2 billion a year in annual revenue. We have science research. We're going to touch upon that. One of the panel members here will touch upon that later. Media entertainment. So all these various boxes actually currently have companies that are either developing business models or actually making money in each one of these application areas. And those boxes you see at the bottom of the page are not traditional quote-unquote space companies, but they are highly dependent and highly related to the infrastructure boxes above. So theme number 2, Silicon Valley Redux. So here are some infrastructure and application companies that all of you should be familiar with. I would assume you would be. Let's take the internet, for example. So these 3 companies you see listed at the top of the slide are very traditional, hardware-centric infrastructure companies when it comes to the internet. They make the switches, the nodes, the routers, the servers that internet traffic travels upon. They're the pipes, if you will. The companies at the bottom of the slide are those that leverage that infrastructure and essentially funnel zeros and ones in data to make money. The bottom companies would not exist without the infrastructure above, and the infrastructure above generally would not have a market without the applications below. Same exact thing in the space industry. So here are a couple examples of space companies. SpaceX and Virgin Galactic, one of them is represented here on the panel. They are relatively as a, let's put it this way, kind of a brute analogy. I'm sure Will can maybe refine this a bit. But they're infrastructure companies. They build the stuff that get things to space. Here's some example space companies that are application companies. They utilize that infrastructure to make money and provide data or services to the end user. DirecTV, everyone knows that. Digital Globe is a satellite imagery company. And we have Astrotech, which is actually a company that does scientific research using the infrastructure above. So the last theme we're going to touch upon is inflection point. Is this the Netscape moment for space? And there's numerous different things that are kind of working and fueling this type of inflection point. One is, let's continue this internet theme for a bit. Contrary to popular internet folklore, Al Gore did not invent the internet. In fact, it was a coordinated effort of government programs, including the DoD and DARPA, several collaborating universities, that invested quite a bit of money and time during the 70s and 80s to essentially develop the precursor to the internet, ARPANET and other derivatives of that. So what happened with that? Commercial companies now took that foundation in the 90s and completely revolutionized the foundation that government created to what the internet is today. It's basically it's an industry that has completely transformed the social dynamic. All made true because of government spending. At least the foundation of it was. The same analogy can be applied here. NASA, from its existence through to today, has spent about $800 billion in real dollars. 800 billion with a B over the last 50 years. Some of that money, some would say a lot of that money, but some of that money was wasted. A lot of it led to good hardware, IP, intellectual property, like I said, and other things that were leveraged by commercial companies. Some of the companies on the panel here, we'll discuss that in a second. So NASA is now going through a transition. The shuttle has been retired, and a lot of commercial industry is being fostered or catalyzed by NASA involvement. NASA is either a customer or it's helping give money through grants and other activities to these commercial companies. So NASA, because it's going through a transition right now, is actually assisting quite a few commercial companies in what we call new space. The other major thing is that investments are increasing. There are essentially, how would I put this? There's quite a few billionaires or very, very rich people that are developing their own space companies. Elon Musk of SpaceX, Jeff Bezos of Blue Origin, Bob Bigelow of Bigelow Aerospace, developing companies that are viable, some are making money, and kind of blowing through the obstacles that they faced before them. And some in the industry view this as kind of a catalyst for growth. Look at one successful company here or another one there, and others will follow. So investments are increasing. One thing that I do with one of the hats that I wear in the space industry is I work with an organization called Space Angels Network. We're basically an organization of about 20-plus angel investors here in the US that invest in space-related deals. So we have seen an uptick as well in the number of space deals that are occurring. So investments are increasing in what we call commercial/entrepreneurial space. And several companies are actually positioning themselves right now to enter the public markets, which is a revolutionary thing for commercial/entrepreneurial space. So one company, SpaceX, some may say, is positioning themselves to enter the public markets. And some in the industry kind of argue that what the space industry is going to encounter soon is essentially what we call a Netscape moment. A moment in which the industry is going to take off. When one company becomes highly credentialized, others will follow. So, as many of you remember, back in the mid-90s, the internet was just an idea. Several investors, Kleiner Perkins being one of them, put money into Netscape, and everyone was off to the races. This is not going to be as big, and I hope it's not going to be a bubble, but the space industry might encounter the same thing due to the various factors and influences we're seeing that are converging right now.
So let's start with just a little recent history lesson about how about 100 billion of the 800 billion he talked about has been spent. In 1998, the Russian Zvezda module and the US Unity module were connected in space. This started the construction of the International Space Station. This is in September 2001. And beginning in November 2nd of 2001, the space station has been continuously occupied. This is it in December 2001. This is further along in the development of the International Space Station. Now, in final completion, it weighs about it weighs close to 1 million pounds. It orbits the Earth every 90 minutes. It has a crew of between 3 and 6. 4 different vehicles visit it at least once a year. Each of them visits at least once a year. And if you look way down where that arrow is, in that module, is where NanoRacks is. Within that module, about 30 years ago, NASA developed a rack system that they call for using experiments, similar to what you'd find in a data center. The racks are about the size of a large freezer. And within those racks, they were designed about 30 years ago, back when things were much bigger. And so our business has been to take that rack and basically subdivide it out. So here is a video of July of last year, astronaut Doug Wheelock installing our payload in the module in the International Space Station. We have 2 racks already there. We have another one planned. So here what he's doing is he's taking out a tool that's a divider. There's a series of USB ports on it. We sell payloads in the CubeSat form factor. So you'll see there's a couple of 1U cubes already on there. And he's going to, in a little bit, you'll see him install a 2U payload. That payload that he's about to install, you'll see him pulling out the wrappers from Valley Christian High School just down the road here. It's a plant growth experiment. And so here he's opening up it, and so he'll install that in our tool. And so we hold 16 cubes in the rack. And so here he's taking it out. And so our client base includes a variety of high schools and universities. That was sort of the initial base of our clients. And as we've proven out the platform, we've added a lot more. So he'll connect it to the system, and then he'll use the laptop to connect to it. They're getting ready to roll out a Wi-Fi network on the International Space Station, so our clients will have real-time data access to it. So the payloads are provided with data access through the USB port, as well as with power. So, and this is just sort of in a minute and a half, sort of shows you building the payload. So, in the platform, we have 2 platforms up there. Like I said, we've settled on the CubeSat form factor, which are 10 centimeter cubes, and it's a standard interface. Our pricing for a 1U cube is 30 days on the station, starts at $25,000. And we're also getting into the business of putting equipment onto the International Space Station. So in addition to customers wanting the payloads, they want to do analysis. We've already flown 2 microscopes. These are microscopes that were off-the-shelf Celestron microscopes that we bought and purchased and paid to have flown to the International Space Station, and then our customers pay us for usage of the microscopes. One is a microscope like you'd use for viewing cells, and then another one is one that you can use for sort of scanning things. So for example, they use it to scan the spacesuits after spacewalks for micro damage. And we're getting ready to fly a thing called a plate reader. A plate reader is a mass spectrometer that's used in biochemistry. There's over 1,000 of these in labs throughout the country. We took one from a company called Molecular Devices. We've made some modifications to make it space-worthy, and this will then add to the capabilities for our bio customers. And so we're getting ready to roll out a platform, our 3rd platform, that'll be geared towards the bio community. In the bio world, there are, in addition to, they want larger payloads. So these are 4U payloads, so that's 4 10 centimeter cubes, imagine. So when you talk about the CubeSats, everyone talks about 1, 2, or 3U. They're just basically, imagine 10 centimeter cubes sort of stacked together. So these are 4U payloads. They have higher power, higher data rates. And for the bio customers, they're also interested in what's called early and late access. So right before the rocket takes off, they want to put their payload on. And right when the rocket lands, they want to be able to get their payload off. We had one customer that got their payload from the steppes of Kazakhstan to our shop in Houston into the customer's hands in under 11 hours from landing on the ground and into the customer's hands. The other platform we're also going to roll out is an external platform. This will be one that will allow customers to be able to test components in the space environment over long duration, to be able to test in the vacuum of space. And so we're expecting to roll that out in about 2013. We're in the process of signing an anchor tenant for it. So as you can see, it's sort of a real estate business model where we're purchasing wholesale facilities on the station and then selling pieces off from that and selling usage on those facilities as well. So some of the interfaces that the customers deal with is the first one we have here is the CubeSat. So this is the cube here. It's the 10 centimeter cube. And so the next payload we're getting to roll out is this one, we call it the mix sticks. So if you imagine the glow-in-the-dark sticks that you have in Halloween, you break them. This is how we're going to be conducting experiments as well. These mix sticks, each individual stick, we'll be able to, we're selling those for under $10,000. So it's a quick and easy way for people to be able to do lots of fluid experiments. And in fact, the customers get significant volume for the experiments that they're able to do it. And then the other one is for the plate reader. These are each one of these is used by the plate reader for looking at the various biosamples and things like that. Big question that we get from a lot of people in the space community is, well, with shuttle going away, what happens to your business? There are 4 vehicles that currently fly to the International Space Station: the Russian Progress unmanned cargo vehicle, the Russian Soyuz, which is currently the only manned vehicle to be able to get people up. There's a Japanese transfer vehicle and that takes cargo, and as well a European transfer vehicle. Currently, the only way to get payloads down from the International Space Station is through the Soyuz, but there are several vehicles in the works. So the 3 major ones are, obviously people have talked about SpaceX with the Dragon capsule. That's going to provide cargo to the space station. One of the big things, the big game changers for the Dragon for us, is that it'll provide tremendous down mass as well, because for the Dragon, the same amount that goes up will be the same amount that goes down, whereas currently for the Progress flights, they basically burn up in the atmosphere when they come back down, so there's no return. So in addition to SpaceX, you also have several companies building ones that are on the Atlas Delta vehicles. So Boeing, Blue Origin, Sierra Nevada are all developing capsules that will go on top of those vehicles that will fly to the International Space Station. And then Orbital Sciences also has a cargo module that will fly on a Ukrainian rocket that they're planning to fly next year. So in addition to the 4 that are currently flying, we expect to have 3 more. So our business is based on having reliable, routine access to the International Space Station. These dates are slightly off with the recent progress problems they've had, but the good news with those is that they were not deemed to be a flight safety risk. They had a problem where the engine cut out at a very high altitude and they lost the payloads, but if it had been a manned vehicle, they would have been able to bring back the astronauts. The biggest number that we are most proud of as a company is that the average time from a customer signing to flying to the space station is 9 months, which in the aerospace world is pretty fast. And we've flown 27 customers so far in under 2 years. We have a backlog of about 50 customers, and we'll talk a little bit more in a bit about our customers here. So we just are announcing now, this is actually the first time we'll be announcing in English, that we've signed a deal with the Saudi Science Center. It's a 3-year deal for doing payloads for Saudi universities. We held a workshop for them just this week in Saudi Arabia for them on how to design the payloads. We've been holding these workshops throughout the world. We held one in Germany for DLR, the German space agency. We have the Fisher Institute that's flying with us. It's an Israeli institute that is doing some biochemistry experiments, as well as they're now beginning to do some water filtration experiments in zero gravity as well. And we also have Vietnamese customers and then several in the US. So the big question is, so for a lot of you, I know you're very interested in the entrepreneurial space business. And so what are sort of the lessons learned? The biggest lesson that I can tell you is that things are changing rapidly within NASA. Our business would not have existed 10 or 15 years ago. If you want to know why, go read my boss's book. He wrote a book about the Mir space station and everything that went on then. NASA has made dramatic changes since then, and so being able to do business with NASA has changed. And remember, NASA is a huge place. There are tremendous resources buried throughout the organization that you have to look for to find. There's 11 centers plus headquarters, and they all have all sorts of interesting stuff within there. And the easiest way to get access to the technology within NASA is what's called the Space Act Agreement. And so a Space Act Agreement will either get you access to NASA technology. A great example of that was about 10 years ago, the Space Shuttle did a full coverage of the Earth, a topographical map coverage of the Earth. So they had full geospatial related topographical map of the Earth that they released to anyone. And that eventually became the basis for Google Maps. And so those kinds of data sets exist all throughout NASA. And so as you're thinking about things from, here in Silicon Valley, if you think about all the data that they collect, there's all sorts of opportunities there. And the easiest way to do that is through the Space Act Agreement with NASA. In terms of raising money, not everyone, you don't have to be a billionaire to be in this business, especially if you have customers. For us, our biggest investors early on were Visa and MasterCard. And so we managed to bootstrap the company. We recently completed an angel round. As Amaresh talked about the Space Angels Network, as is true in many industries, the angel networks have really sort of stepped into the breach here and provided a lot more funding than they used to. We recently raised a round. Investors in this round include Esther Dyson, the Central Texas Angel Network, Pete Ricketts, and Near Earth investment bank that specializes in aerospace have all invested in the round. You really want to focus on investors for the long term. You're going to tend to find that people who invest in space industries tend to be the ones that want to fall in love, which I think is kind of true for anybody who's investing in a startup. We're creating a fragile ecosystem. There's a guy here named Rob Call here who's here from a company called Pumpkin. and they design kits for CubeSats that are similar to the payloads that we build, but they go out in space. And they're now beginning to design products for us as well. They're taking some of the products that they built for CubeSats and are adapting them towards our platforms on the International Space Station. They did this all on their own. We found out about it when they released the product. And we think that these are great signs that an ecosystem is developing. And so as we develop more routine access to the station, we'll be able to develop this ecosystem. And the biggest message we want to leave you guys with here is that as you're planning out your futures in conquering the commercial space industry, think about how you can use NanoRacks to be able to enable those businesses. In the latest round of, for example, in the latest round of NASA SBIRs, we supported over 15 proposals. We're well set up so that if you've got an idea of something you want to test in space, we can help you with that in terms of whether you're writing things for SBIRs or business plans or anything else like that. We're willing to help you with supporting, getting the funding. We understand that it's a long-term process and we want to build these relationships. And the International Space Station provides an incredible platform to be able to do things for a lot cheaper. Because it's there. We've spent $100 billion on the station. We've developed this facility. There's astronauts up there. They can do things, and so it's really proved. I think we've really proven that having people in the loop can really lower your costs. So, for example, even simple stuff of just installing the payloads, of installing the USB drives, working with the infrastructure on there, we're able to do things at a much lower price than you would if you were going to fly them on standalone secondary payloads or anything else like that. The space station provides a tremendous opportunity to be able to test all these things and be able to do it in space. And so now, rather than just sort of guessing and hoping and wondering whether or not things will work in space, we think we've provided a cost-effective way for people to be able to test these things in space, to be able to do research, because there's a tremendous amount of work to be done. Our initial client base started with high schools and universities. Some of the work that they're doing is incredible. And now we're beginning to move into the research community, and we see a big bottleneck there's a big disconnect between people who have payloads that want to fly and up until now, the lack of people flying it. We think we've helped to be able to do that by just simple, basic business. This is when Esther Dyson invested. She said the reason why I'm investing in this is not because this is what we need in space. This is not a technical innovation. This is a business innovation. And so the technology we're using is real simple. It's off-the-shelf stuff. That's why we're moving towards open standards. And so we think that in the long run, simple business, the cheaper you make it, the more customers you find. And that's certainly what we're finding now. So I appreciate your time, and thanks for the introduction, Amaresh.
NanoRacks is probably one of the prime examples of how new companies in the new space industry have started from scratch, raised funding through various financial channels, and crossed the gamut between infrastructure and applications that we talked about before. So they'd be akin to, I don't know if you pardon the analogy, but maybe Apple. A great cross-section between actual hardware development and use of hardware and enabling applications, in this case science experiments and other experiments that can be done in space. So there you go, the new Apple of the space generation.
Well, it's funny you bring that up because we have a client that recently flew the first iPhone into space.
There we go.
And so they're using that as a platform for data collection and a computing platform for the payloads that fits well within the cube.
Very good, very good. So throughout the panel here and maybe before, prior to the panel, we may be throwing around space-related terms that sound either geeky or stupid. Feel free to approach us afterwards and we'll answer any questions you may have that are specific to certain terms. But let's start with the panel here. We're going to launch into our panel with our distinguished panelists. The companies represented here are an excellent cross-section of what we call new space and traditional space as well. They cross the gamut between infrastructure and applications, the analogy we provided before in the beginning of the talk today. So let me just go down the row here, and I'll introduce the panelists, not in detail. Their bios are in your pamphlets there, just to jump into it. So Will Pomerantz is with Virgin Galactic. And as many of you know, Virgin Galactic is backed by Richard Branson and the Virgin Group. Very fascinating company. You probably read about them before. Will, thanks for joining us.
Absolutely, my pleasure.
You've all met Rich Pournelle. We have Al Tadros with Space Systems Loral. One of the offices local here. Space Systems Loral is an excellent company as well that transitions between infrastructure and applications. They're a satellite and satellite services company that I think enable numerous applications that we touched upon before at the beginning of the presentation today. And we have Dr. Bob Richards from Moon Express. And Moon Express is, among many things, is a Google Lunar X Prize company. And one of the many things they'll be doing is enabling lunar commerce in a commercial way. So please welcome the distinguished panelists. So what we'll do is we'll try to keep this very lively, very discussion-oriented. If you're disappointed, throw tomatoes. We will start with a general question that will probably go down the row. And with that, we'll kind of ask more specific questions to each company. So I'd like the panelists to spend maybe a minute or two just talking about their company and providing an overview of their company to the audience here. So Will, would you like to start?
Sure. Well, hello everyone. I'm Will, as Amaresh mentioned. I'm from Virgin Galactic. And the whole idea behind our company, and really, in fact, a lot of our companies here, is that we need to make access to space way more prevalent. We have to democratize access to space. You know, as of today, you can fiddle with this number by 1 or 2, depending how you count it, but about 525 people have been to space since Yuri Gagarin flew in 1961. And on the one hand, that is a very impressive number, right? No other species in history has sent even one. To have sent 500 is really amazing. On the other hand, that is really depressing, right? This was done in the 60s. Those of you who grew up in that time period and those of you who grew up since probably all grew up thinking, well, by the time I'm an adult, I'll get to go. We all watched 2001 and saw that regularly scheduled Pan Am shuttle up to the space station and onto the moon, and we thought that's what we were going to be able to do. But the fact of the matter is that that is not NASA's job. And that's not the Russian Space Agency's job, and that's not any other space agency's job. It's not that they couldn't do that if we asked them to do that. There's a lot of very smart people working at those agencies. But that wouldn't make sense. Why would a government agency's job be to make you all able to go to space? So as Sir Richard Branson, founder of my company, was looking at this issue, and he's one of those sort of frustrated children of Apollo who thought he'd be able to grow up. He grew up and travel routinely. He realized this was only going to happen if a private company made it happen. So in 2004, this vehicle called Spaceship One flew into space. It was the first privately built vehicle to carry human beings into space. It did it to claim a predecessor to the Google Lunar X Prize, this $10 million prize called the Ansari X Prize. That vehicle now hangs in the Smithsonian. It was a pretty big deal when it happened. And that was kind of the proof positive that Richard needed to think that, you know what, this is actually feasible. It's not just desirable, but it really is feasible. So started Virgin Galactic. We have built and are currently testing essentially an evolved generation of that vehicle that successfully flew in 2004. Whereas that vehicle could only carry 3 people, including pilots. We're now building an 8-seater, so that'll be 2 pilots and either 6 human passengers or sort of their weight equivalent in scientific experiments. And we have other ambitions to go from there.
Great. Thank you very much, Will. Rich, we heard from you, so Al, please.
Absolutely. If you don't mind, I'm going to stand up, if that's okay. This is a very exciting topic, and even more importantly, it's an exciting event because it's a hometown crowd. I've lived in Palo Alto area for 22 years, working at Space Systems Loral right down the road from here. Space Systems Loral has been here for over 50 years as part of the Silicon Valley community. So this is seeing family and friends, colleagues, and customers, local companies, and so forth has been great. That's really the first point, is this is an existing industry here in your community. This isn't something in the future, or this isn't a maybe next year or maybe 5 or 10 years. This is right now happening here in your community. We are the world's leading satellite communications company. So who here has DirecTV? Dish Network? Sirius XM Radio? Who here watches any TV at all? So even cable TV gets distributed by satellites to nodes that go out to local TV companies. So satellite communications is prevalent. Those are the consumer recognizable product names. A big part of our customer set are fixed satellite services. We also have broadband services that I might talk about more. But commercial communication satellite services are prevalent in our lives. That's not to mention the imaging and navigation services which you use just about every time you go into your car or try to find a product on the street or so forth. That industry of services has really been the engine to drive technologies that we build here in Palo Alto. We build over 40,000 pieces of composite structure for our satellites. We assemble propulsion systems. We build electronics and microwave components. We do all those here in Palo Alto under commercial contracts, delivering satellites in 24 to 30 months to our customers. So they can put a business plan together, they can put us under contract, they can finance the venture, and within 3 to 5 years they have a service up, running, generating revenue, $50 to $100 million a year of revenue. That's what we do at Space Systems Loral. There's another aspect of our business that's just starting to evolve. As the government is recognizing that they can't do everything on their own, that they can't build unique satellites and services on their own, they're actually turning to the commercial industry to say, what can you do for us? So we've seen recently the DoD for military communications coming to commercial communications companies and saying, hey, look, you're building, satellite to smartphone communications right now. Most of the warfighters go to the battle zones. They have more communications in their bedrooms at home than they have in the battlefield. We are building and we are enabling services right now in the commercial industry that surpass what the founders of the space industry, the governments and the militaries, can't do for themselves. So that's the final point I wanted to share with you, is that we're not only an established and thriving business, but we're also giving back to the government that started basically all our businesses 50 years ago, including Loral here in Palo Alto. Thank you.
Thank you, Al. You took a generous 1 to 2 minutes, but that's okay. Al's company, Space Systems Loral, is one of what I would call a traditional space company compared to the rest of the panelists here. The term we coined in the beginning of the talk today, new space, which has been coined elsewhere, is basically composed of companies that are relatively new, but also interact with more traditional space companies like Space Systems Loral, and vice versa. So all these companies are part of the larger ecosystem that we discussed. Bob, please.
Sure. Hi, everyone. My name is Bob Richards. I'm the co-founder and the CEO of Moon Express. I guess I've been involved for about most of my life, actually, in building the institutions, the companies, organizations that will help create a multi-planet civilization for humanity, when I look at really what's been the driving force. I was a founder of the International Space University, which educates graduate students. Woohoo! Woohoo! How many people here have touched the International Space University? All right, what a posse. Thank you. And co-founder of the Singularity University, which is homed here in the Valley, modeled on the ISU. How many people here are touching SU? Not bad. Students for the Exploration and Development of Space, another woohoo.
That's right.
And, but perhaps most exciting of all the ventures I've ever had the privilege of being involved in is Moon Express. And when we're talking about creating a multi-planet civilization, the Earth is in a very unique, is a very unique planet because we have a sister world so close to us. It's very unusual, actually, when you look out into the cosmos to find a world like Earth with a world so large like the Moon. So if you were a Polynesian looking at exploring and going out into the ocean, and you saw an island on the horizon, this would be the same sort of inspiration the Moon gives us. It's a destination that's very close at hand. It's only about 3 days away. And it's a whole world of opportunity, and Moon Express is about creating an economic relationship between the Earth and the Moon, something that benefits all of us here on Earth. As we become a multi-planet species, and it's not a question of if, it's a question of when. There's a pretty good chance a big asteroid is not going to wipe us out next Tuesday. But it might happen. And eventually we need to have more than a single point of failure. So Moon Express, I want to point out my co-founder, Barney Pell, if you wouldn't mind raising your hand. Very, very successful Silicon Valley entrepreneur who also spent many years at NASA. Actually, if I could maybe point out, we have a posse here from Moon Express. Everybody from Moon Express in the back there, could you raise your hand? Could you also stand up? I want people to see you. Please stand up. And I want you to take a note of the age range here, okay? We are going to the moon. And it was the 26-year-olds back in the 60s who created the Apollo program, mostly because they didn't have the middle managers. They couldn't tell them what couldn't be done. Thanks, guys. We have an incredible team. I'll talk to you a little bit more about what the business case is behind Moon Express. But if all works well, we'll be the first private sector company to land a robotic spacecraft on the moon and identify resources, materials that are very important to all of us back here on Earth.
Thank you, Bob. So when I was chatting with Ron earlier, one of the chair people of the VLab organization, he was skeptical of a space event. And when I first entered the space industry, I was highly skeptical as well. It took a while for me to kind of jump ship from a traditional job to an entrepreneurial job in an area called space. But one of the themes or arguments that people always ask is how far away are companies from actually making money in this industry? Making money meaning a startup in this industry, an entrepreneurial company in this industry. So I'd like to ask, well, maybe Will, would you like to chime in on that? What would a conventional break-even point be? Or when will companies start making money if they aren't already for an entrepreneurial space company?
It's a good question. I mean, there's probably a huge range. I think one of the difficulties, especially as a lot of these companies try and get their start, is we can't walk into a standard Silicon Valley VC and say with the kind of certainty that another internet startup can what our returns are going to be over what horizon. But they're starting to see some very good data points, and I think we at Virgin Galactic are maybe one of those points, or at least hopefully will be in the future. Just to give you a sense, we were founded in 2005, sort of late 2004, early 2005, started taking reservations not too long thereafter. As of today, we've got something like 450 seats sold. So we're getting pretty close to that 525 number. Hope to cross that line soon. Our seats are $200,000 a pop, gets you into space, and on that most exclusive list in the world. We've taken somewhere just shy of $60 million in deposits already on those seats for somewhere on the order of $100-ish million in sales. So I guess we're already making money in that sense. We've also, in late 2009, sold approximately a third of the company for approximately $300 million, and so that was a nice sort of market valuation for one of these edgy, strange commercial new space companies that provided a real data point. So we've been bringing in revenue in some sense for a while, and hope to be, we hope that is just scratching the surface. We carry 6 people per flight and are built to fly multiple times per day. So we're going to be hopefully bringing in a lot more revenue on a lot more flights in the not too distant future.
Great. We talked about earlier as well, and before I get into the next question, you probably see some colorful slides flashing overhead. We're trying a new system today. You can actually text questions in, and that we'll ask a little bit later, and the text number is at the bottom right corner of the slide. We can send a man to the moon. We can definitely do texting questions in an audience, so let's try it out. The next question we'll run into, I think, is regarding NASA. So we talked about government spending, how it enabled the internet. NASA spent about $800 billion in its existence to do various things. How has NASA helped or may help your company in the future? Bob, can you take that one?
Sure. Actually, there's 2 sides to that coin. NASA is a customer of Moon Express. We were one of the companies selected by NASA for a contract called an Innovative Lunar Demonstration Data Program. A lot of words, ILDD, a NASA acronym. But it's about NASA agreeing to buy data from a commercial lunar company. So it's not a grant. It's not a contract where NASA asks us to do something for time and materials. It's basically a fixed price, performance-based contract, of the same nature that SpaceX uses for going cargo and humans to the space station. It's a contract that's worth up to $10 million. However, it's given out in chunks. We're one of the 3 companies in the United States that were given the first task order to earn $500,000. We are developing a space system to go to the moon. And NASA can learn from actually entrepreneurial activities, and they're willing to pay for the data based on success to do that. That's the customer part. On the other side of the coin, we're also partnered with NASA. Rich, you mentioned a Space Act agreement. We have a Space Act agreement with NASA, a special kind of Space Act agreement. It's called a reimbursable Space Act agreement. So there's a member of the space generation. Guess what? We pay NASA. This is, I think, the only federal agency that has a contractual mechanism that allows a private sector company to basically hire a government agency. So we're turning the business equation upside down. Rather than a large government entity putting out a requirement document that private sector responds to, we are able to define our own business case and pick and choose the best of what NASA has to offer that fits in with our matrix of needs. So it's this double-sided coin, customer as well as partner, that we are finding, and I don't think this could happen anyplace else other than Silicon Valley with our partnership with NASA Ames, actually, that we're finding a very affable, a very cooperative, and a very positive partner in NASA, as well as a very important customer that helps validate us to our investors as we complete our technical program.
Okay. Al, I'd like to get your feedback on this following question. It's regarding, as I said before, Space Systems Loral is probably more of a traditional space company relative to the rest of the panelists. How is Space Systems Loral working with startup companies in the space industry, or how do they envision working with new companies in the space industry?
Sure. Well, we regularly work with a number of services companies, satellite services companies, so they have a market, they have a purpose to serve a segment of either their country or cities for broadband or some vision along those lines. And we start oftentimes working with companies at that stage. All they know is they want to provide a certain bandwidth or certain capability for a certain region. And we basically develop a space system, an architecture that interfaces with the terminals, the antennas, whatever it is on the user side that they need to deploy and communicate with. So we have an aspect of our company that regularly works in that environment. I should say that a lot of times it isn't a whole satellite that these companies will own. There are small companies out there that are looking for a small, relatively small communications capability, and they can get matched up with another company and they can share a satellite, and a lot of them leverage the investment on both sides to do that. A final item which I alluded to earlier is that the technologies that we've built off of these communication satellites are also available to some of the startups and the ventures. So as an example, actually local here, NASA Ames is building a small lunar orbiter right now. We are building a propulsion system based on our communication satellites for that capability. So lunar X Prize type of, Google X Prize type of systems that are going to the moon can leverage capabilities that we've developed on commercial contracts. Those are a couple ways that we work with new companies.
Great, thank you. So I think we'll do audience questions soon. I'm going to ask one more question of the panelists here, and Rich, this is for you. There's been a recent movement, I wouldn't say it's relatively recent movement, what I would call miniaturization of space hardware. So as all of you know, it costs a lot of money to launch mass into space. The heavier you are, the more it costs. The going rate now for a relatively cheap launch is about $10,000 per pound of payload. NanoRacks, you got the word nano in the name of your company, so maybe you can comment on what you think the miniaturization of space, what it's doing currently, where it's headed, and how does that enable your business model?
Well, I think a lot of trends in other areas have really driven that. As computers have gotten smaller, that allows you to be able to do much more work within that. We do offer a fairly constrained environment for customers in having to build stuff that small, but in any business, it's the footprint is going to be part of your price. So I think ultimately most of the benefit that we've seen from that has been from other areas in semiconductors and cameras and actuators and things like that. I think just in general, the thing you've seen over the past sort of 20, 30 years is that it's a lot cheaper to make stuff now, and so whether it's machine tools, being able to go straight from CAD drawings to 3D printers, the whole process of doing small scale custom manufacturing is a lot cheaper. It's a lot more efficient. The supply chain's a lot better now. And so I think that the trends, both in supply chain as well as in electronics and other miniaturization, I think really drives a lot of that. In the past, I think one of the things that you've seen, in the past, the electronics, space qualified electronics have been, the other big thing is you've got the space qualification process. In the past, space qualified hardware has tended to be very behind the curve. I think the Hubble telescope is, I think, run by a 486 computer, and that was an upgrade from the 386. So the flight computers in the shuttle were fairly, they weren't state of the art, but they were proven. They work in the space environment, and so that's one of the constraints that you also find is that flying the same thing over again tends to be a lot easier. And so if you can come up with ways to be able to test that stuff, be able to do real world applications, and you can do more of the miniaturization with that. I think one of the big exceptions that I think has been Loral, where it's very, the customers are spending tons of money with getting more into the transponders and into the spot beams and things like that, where that's probably one of the areas where you very much are further out, I think, on the curve with that, because look at the amount of money that they're making with that.
In the payload side, yeah, but I got to admit, on the bus, on part of the satellite, they require a lot of heritage, a lot of experience, a lot of proven time, and up until recently, we've used the 1750A processor. So it's very much hard to change and evolve as quickly as terrestrial consumer electronics and so forth.
Didn't the shuttle originally use reel-to-reel data drives? And I believe the Apollo missions used an 8-kilobyte computer. Is that right, Bob?
Well, they just released some of the details of this NRO program where they were taking pictures of the entire world with film the size of your dinner table.
Oh, right.
So I think we've come a long way. And then they were dropping that film out from space.
Okay, let's open this up to questions from the audience. So like technology magic, as you text your questions in, they'll be filtered and then arrive at my little iPad right here. So no stupid questions, please. So let's start with, Will, this is for you, actually. How much will a seat cost 50 years from now, and will the majority of the audience be able to go?
Boy, I sure hope so. I want to go. I can't afford our current ticket price. That's the beautiful thing is space has always been expensive, but if you get down to the physics of it, it doesn't need to be anywhere near as expensive. Rocket fuel is not, colloquially we think of rocket fuel as the most exotic, high-tech thing that we're going to go mine from, Neptune or something. Generally speaking, our rocket fuel is tire rubber and laughing gas. Most rocket fuel is ethanol and kerosene. It's not really exotic things. It's not terribly expensive. The cost of putting gas in any one of these spaceships and going to orbit is, usually measured in the thousands of dollars to tens of thousands of dollars. It depends how big the launch vehicle is. And when you start getting, as we are trying to get and other companies are trying to get, when you start getting to aircraft-like operations of your spacecraft, that price can really come down. The space shuttle, great vehicle, just retired after a wonderful career. It works out to that vehicle cost a little over $1 billion per flight. Again, it wasn't gas. It was a standing army of very well-qualified people that were maintained to fly that vehicle, and it flew on average, maybe 2 or 3 times a year over its lifetime. We want to fly our vehicles 2 or 3 times a day with a much smaller workforce. So I think our ticket price of $200,000 won't stay there terribly long. We do have to amortize our development costs, and that's not trivial, but we can get past that fairly quickly and get down to the price. We sort of talk about a target of hitting the SUV price. When we can make a ticket to space the same as you would pay to buy a new SUV for yourself, I think that's something that almost everyone can afford, whether it is just for pleasure, and we do have a lot of tourist customers, or certainly if you're doing it for research purposes for your company, for your academic lab, that scientific labs can spend that amount of money pretty easily.
Great, thank you. Bob, is Google currently investing in the space field? Can you talk a bit about the Google Lunar X Prize?
Sure.
And what's the incentive for Google to do so?
Oh, well, I'll speak to the former, and I can speculate on the latter.
Okay.
So Google has offered a $30 million purse. I should point out that Alex Hall is here in the audience, who runs the Google Lunar X Prize for the X Prize Foundation. And I got involved in the Google NanoRacks Prize shortly after it was announced in 2007. It's a $30 million purse for the first privately sponsored team with no more than 10% of government funding, so 90% private sector financing, to be able to reach the moon with a robotic spacecraft, land safely, take high-definition imagery, video, data, from the landing site and from 500 meters away. And if you can do that, you can win the first prize of $20 million. And then there's a series of bonus prizes totaling $5 million. And another $5 million for a second prize. It's a $30 million purse, which has been an incredibly positive catalyst for 26 teams now, I believe, that are competing worldwide for this prize. But I think perhaps most importantly, in the public mindset, Google thinks this is an important thing to do, and thank gosh they do. It's created a social network of people, young people in particular, that are being inspired by this. Many of us are orphans of Apollo in this audience, me included. And today there's a whole generation of people that never knew that excitement of trying to reach another world. And this young generation of people that are now working to get back there are going to realize this. I think, I know Larry, I know Sergey, and I've had personal conversations, and they've explained, and so has Tiffany Montague, that Google is doing this because it's a cool thing to do. And it's a really important thing to do. It's symbolic to redefine what people's perspective is of what is possible. And with that type of transition of convinced minds, the future is really ours.
Thank you. Al, can you take this one? Pretty much every economic discussion that occurs in the U.S. now always references China to some degree. How China's industry and GDP are going to overtake ours and the various competition that could exist between the two countries. So how does the U.S. space industry view the Chinese space capability, and do you foresee any major collaboration in the satellite realm or other realms of space? Okay,
good question. Informed question. So the space community here in the U.S. is basically buffered through the State Department by what's called ITAR. So there's very limited opportunities to collaborate, especially in the commercial industry, with China, including launch vehicles, components, selling capabilities to them, and so forth. So for the foreseeable future, I don't envision collaboration. However, the Chinese clearly have a very capable space industry and kind of reminiscent of the early Soviet space industry in both unmanned and manned systems. So they have demonstrated manned launch vehicles, spacewalks, assemblies, rendezvous docking kind of capabilities here in the past 5 to 10 years regularly. So they're on their own advancing their capabilities. There's satellite communications technologies, although so far hasn't been demonstrated as reliable and as capable as the U.S. and at Loral. We definitely have them on the radar with regards to, in the next 10, 20 years, what they might be able to do and compete in the international community.
Okay. Thank you. Rich, what is the plan that NanoRacks has in place for when the International Space Station is deorbited or its end of life? Maybe you can talk about what the future is for the space station, what your business plan accommodates for the next wave forward.
Well, there is the... they always put extra margin in these things. They have NASA's had some bad luck, I think, with the press lately, where sort of contingency plans got out. So, for example, a few weeks ago, you may have seen the headlines: NASA has plans to abandon space station. NASA always has plans to abandon space station. They have all sorts of contingency plans. They have body bags on the station. They prepare for everything. So the station, currently is set for the next 9 years. Through 2020, the partners have agreed to support it, and we think that it'll probably continue well beyond that. I think the hardware that's on there has shown a long useful life on it. At some point, there will be some decisions about what they have to replace and what needs to be refurbished and what needs to go and what needs to stay. But in the next 9 years, I think we can do a lot of business there, and I think that's going to be part of part of the ongoing continuation. The future of the station is really going to be dependent upon what happens with research on the station. If we're getting, currently there are over 600 principal investigators working on experiments on the International Space Station, and as those results, I think, move more towards the commercial side, I think that's really going to be a big driver for all this. So. Recently, there was some legislation passed that also created a national lab organization. So what that does is it really sort of moves some of the decisions to an independent entity for deciding what goes on in a major portion of the station. So I think the future is bright. I think people throw out dates and contingency plans about this, that, or the other. But the reality is that the success that we demonstrate on station, I think, is going to really drive what happens beyond 2020 for station.
Just back to you, Rich. What do you think the most compelling science research experiment that you currently are doing with a client or will do in the soon future?
Obviously the bio pharma side of things, I think, is really where we're gearing up the most, just because we see that that's really where the low-hanging fruit is. We think that there are some things that need to be tailored towards that community that I talked about earlier of getting early and late access to the payload, so right as they go and right as they come back, being able to get the equipment on the station. But the reality is that there's a lot of different things. We know very little about gravity. Right? It's really one of these forces in nature that there's still a lot that's left unanswered. And so that trickles out into a whole bunch of different areas. And so you have sort of the basic research into sort of gravity and its effects, and then you have the ability of using microgravity to isolate other variables. So for example, combustion research. Flames burn in space in perfectly round shapes, and so they've been able to do combustion research for developing more efficient car engines and things like that. So I think the area, so I guess to sort of the short answer is you've got bio, and then we're beginning to see the other area that we're beginning to see a lot more emerging is in green tech types of things, where we're seeing plant growth experiments, and we have a customer that's doing water filtration experiments, and so isolating gravity as a variable for how the reverse osmosis stuff passes through. But the reality is that some of the experiments, I don't even know half the stuff what these guys are doing on there, and we can't even talk about half of it. So I think you'll see over the years, hopefully, the fruits of the research along the way.
Excellent. So Will, if I make it big one day, which doesn't look like it will, but if I do.
Fingers crossed for you.
Fingers crossed, exactly. Knock on wood. What about vacations to the moon? What's next after suborbital tourism for Virgin Galactic? What could I look forward to and buy a ticket on?
Well, it may surprise you to hear this, but Richard Branson is kind of an ambitious guy.
Really?
And, and his plans for Virgin Galactic do not end at suborbital. That is a very important step number one. It's a hard step. It's one that we as a company are focused on with kind of this laser beam focus. But we want to go beyond that. The idea that Richard is most excited about, that maybe isn't too far down the road, is the idea of taking a vehicle maybe fairly similar to the ones we've already built, but instead of taking off from Spaceport America, this beautiful purpose-built spaceport that we have in southern New Mexico, and landing at Spaceport America, what if you took off at SFO and you landed at Heathrow 45 minutes later? That is an idea that has some appeal, not just because it would be a pretty fun ride and a nice view out the window, but also there are a lot of reasons that we still, even though, especially in this city, mainly we like to move electrons around these days, we still like to move atoms every once in a while, and we like to move them quickly. So that's a hard problem, but it's one that we would like to take on. And then orbital tourism and orbital research. You mentioned Bigelow Aerospace in your introduction, and I think they're a really fascinating company, founded by an Earth hotelier, now starting space hotels and lunar hotels. Yeah, Richard's all about it. He wants us to have it done tomorrow. That won't happen. But we want to do all that stuff. And I think there are people out there, you know, as all these companies are proving, there are people out there who will pay for it. It's amazing to think that every scientific researcher since the dawn of science has all worked, every single one of them has worked in the same laboratory, right? They've all worked in somewhere that is 1 atmosphere, 1 G, with a sun that's 1 U away, a day that's 1 day long. There's a reason all those variables are set to 1. They're all defined as what Earth has. You can go to space and you can isolate gravity as a variable. You can have sunrises and sunsets every 45 minutes. You can have 1/6 gravity or 0 gravity. You know, you can do all these different things that allow people to play. And when you go to the scientific community, when you go to the research community and you say, wow, here's something totally new, it doesn't take people very long. You know, you come to a place like Silicon Valley, like Stanford, like MIT, the wheels start spinning pretty quickly and they find ways to rush into that void.
Good. Bob, what are the technology bottlenecks that you see are kind of slowing down the rate of improvement in space travel or space access or accessing lunar materials, for example, in your company? Are there any major bottlenecks that you foresee?
You know, it's not really about technology.
Okay.
You know, physics hasn't changed in the last 50 years. The fundamental technologies that go into rocket science are still the same. There's, of course, innovation in microminiaturization and some propulsion. Technology makes it easier, but it's not a technological play. It's a play of the right economic business case. It's a play of the convinced mind that these things are possible. And it's a dedication to exploration that throughout history has always opened up new economic spheres for humanity. So I just want to maybe parlay that question into the expansion of our technological sphere, which is really an economic sphere. And technology has been the root. If you look back at what was an economic sphere to a human being a few thousand years ago, it was really defined by the village. Technology allowed a village-to-village type of economics to happen and eventually countries. Today we look at a global economy which is enabled by technology. And we're talking three-dimensionally. And if you look at the order of the panel here, we kind of self-organized here a little bit. We're talking about an economic sphere of Earth which is now rising from the surface out to arguably about 250 miles, which is low Earth orbit, which is the domain of NanoRacks with Rich and Virgin Galactic with Will. And then you've got another order of magnitude to 25,000 miles, another economic sphere, and now you have Loral and other geosynchronous-based companies that are pumping billions of dollars worth of commerce through an economic sphere that's now this big. Moon Express is now looking at another order of magnitude to the moon, 250,000 miles away. And our economic sphere, as we explorers utilize the technologies to ever increase our habitat, will lead to new opportunities, new markets. And it'll drive the requirement for new technologies. So it's the drive for innovation, exploration, presence, and human expansion that really draws the technology into the play. And I don't see much in the way of us being a multi-planet and eventually an interstellar species.
Interesting. So the economic spheres of influence that you coined, I thought was an excellent term. Space is obviously an extremely vast place. Even relative to Earth, it's a very vast place as we go up in altitude. So as the companies here kind of represent different economic spheres above the surface of the Earth, each one in their spheres enables different applications for different markets. So space in and of itself, even though in our opening talk we talked about the diversity of applications, and I think Bob's analogy of the spheres of influence or spheres of economic zones is spot on. Al, can you talk about how Space Systems Loral got into the commercial space business and had customers like DirecTV, XM Satellite Radio, and what's preventing other competitors from doing so? So what's the secret sauce that Space Systems Loral has?
Okay, here it is. The secret sauce is no. So how did we get, so right, 50 some years ago we started in the space industry and largely on radar, you know, Philco, as many of you who are, you know, longtime residents in this area probably remember Philco and Philco Aerospace and Ford Aerospace well before Loral came around in the 90s. was working in radars and communications, and the first satellites, the first communication satellites, were built here in Palo Alto for the Army and for the NATO, the Discus series, and others. So it just like I said, the governments here in the U.S. and Europe and Russia and others are really the impetus for a lot of what started. What we noticed in the 80s, 70s and 80s, is that communications started to be a thriving and core infrastructure. So companies like Intelsat were an international consortium of countries coming together to make communications. So it was actually in 1945 that Arthur C. Clarke envisioned putting communication satellites in geostationary orbit. And so the concept was out there, and then the reality of what it could mean started to come around. And since the 70s and 80s, where it was really focused on these big pipe trunking of data across the oceans and from one TV station to another and so forth, it became more and more prevalent. The capabilities to put up something that can disperse 400, 500 channels of TV became feasible. The technologies, the prices of launch vehicles became reasonable for that kind of market. And ultimately, right now, we see in the next 5 to 10 years some tremendous capabilities in broadband direct from satellites. So companies like HughesNet and Wild Blue, which have started to provide broadband capability directly to users. TerraStar and ICO, who provide communications, satellite communications direct to smartphone-sized devices. Those are all starting to come around, again, enabled by a lot of the early government funding in the industry, but then propelled, really accelerated in the 70s and 80s and 90s by the commercial industry itself, revenue from consumers and businesses back into the technology development.
Rich, you and I talked about this topic quite a bit. The late 90s in the Silicon Valley were a fun time. Any idiot with a business plan and a bar napkin could get VC funding. So I miss those days. And I'm sure you do too as well, but I'm not saying you're an idiot, by the way. How much capital does it really take these days for a startup company in space to really be successful? And I know that's kind of a general question. Maybe you can kind of whittle it down to one specific market niche or one segment. But can I or anyone in the audience bootstrap a space venture?
Yeah, I mean, it's. I had worked for years at X-Core Aerospace, which had done the same thing for many years, and managed to attract outside capital as well. You got to. They always ask. Derek Jeter, why do you swing at the first pitch? And he says, because I think I can hit it. And so when you say, well, what makes for a good space company? So what do you think is going to make money? What I say was, without customers, it's just a hobby. And so that's really, I think, that's really what you have to focus on. Is you have to have. You can't have the days of the business plan of, we're going to go raise all, write me a big check and I'll go do something. Those are over because the guys who can write the checks themselves have gone and done it. And so for you to sort of follow along with a business plan, if you don't have the cash in hand, it's not going to work. So, but the good news is that what you have seen, like I said before, is you've seen a developing angel market. And so I think you can... if you've got the customers identified, you can bring them in early. Then you can manage to do it without doing a lot of capital. Another way, the other thing is to focus on deposits. I mean, obviously, I know that last I had heard the Virgin number was floating around 40, and now you're saying it's close to 60, and the number keeps going up, and that. The interest off of that, I'm sure, pays for plenty of parties in New Mexico and Mojave, and it keeps the customers happy while they're going. And I think that's another great example of I think the answer is because the amounts that are there, you got to look at other ways to do it. You've got to look at deposits. You got to look at customers, because not only is that critical for bringing in the money, but it's also critical for knowing what your customers are going to look like. No one wants to hear if I get 2% of the $100 billion market, that's my market. What they want to know is, what do your customers look like, right? How long does it take you to sign them? You know, who are the decision makers there? Where are they getting their funding from? How are they going to make money? Because, you know, especially for us with the business-to-business customers, in the long run, the thing that's going to make our business successful is if our customers make money. And so I think if you can build a business that way, you can, I think, avoid having to sort of spend a lot of time sort of run around searching for money. And the other thing also, and I know Bob, I know you pursued this as well, is getting vendor financing. There's lots of, recessions are a good time to start businesses. It's easier to hire people, and in industries that are in decline or in transition are also good ways there. I mean, the number I can't tell you the number of underutilized aerospace facilities that there are all around, and so it's identifying those resources so that you don't have to reinvent the wheel. You don't have to go and build new stuff. I mean, just down the road here at Ames, they've got wind tunnels that you can walk into that sit empty for long periods of time. I mean, the resources are out there, and so I think you really have to be creative, in how you do this, because you're not going to attract the capitals. Because I think one of the biggest issues for attracting capitals is you don't have the proven exits, right? It's not just the data points are very small in terms of how do you value these companies. The Abar investment deal, that was that gives you one. I know. Scale Composites was sold to Northrop Grumman. That was another one. There's only 3 or 4. There was In Situ that was bought by Boeing. There aren't that many comps out there, and I think that really is one of the barriers to bringing in lots of money. So the only way you can do it is if you have somebody that has the money and believes in the market. That's the only way you're going to get the 10-figure checks otherwise.
Good. So Bob, hope you're ready for this. Here's a hardball question. Is cooperation from NASA a must-have for your company? And kind of a two-part question. You've introduced your very talented team in the back of the room, relatively young compared to the NASA employee, the average NASA employee. I would guess the average NASA employee is 50+. Your team is late 20s, early 30s. So I guess two-part question is NASA essential for your company? And how do you handle the legacy and interaction differences between your talented entrepreneurial team and NASA?
Those are great questions. So first of all, the markets that we believe in connecting the worlds, searching for the spice, enables a business opportunity that would not necessitate NASA. However, the opportunities we have of partnering with NASA, it just makes so much sense, not reinventing the wheel or reinventing the rocket or reinventing whatever type of technology, learning from so much amazing work that's been done in the past and being able to tap into the minds of people that were there and did it. So it was essential to the business concept that I first approached my co-founders with, that we had a relationship possible with NASA that would enable us to harvest lots of technology and lots of R&D that would be a non-capital cost. So it's certainly a pick-me-up. Now, what we've learned also working with NASA is these are believers too, right? The people in NASA are there for a reason. They're all motivated by the same the same passions and the same things that drove us to believe that 2001 was going to be a multi-planet world back in the day. So working with these people is really a dream, because they might be constrained by a different world, different set of risks, different set of mandates imposed on them by their ultimately congressional leaders. But as individuals and people, there really is no gap. We all share the same passion, and we're able to. There's not really a bridge that has to take place in most cases. Of course, there's lots of bureaucracy in such a large organization as well. And in that case, a bureaucrat is a bureaucrat for life, and a bridge too far, no matter what business you're in.
Right. So I think that'll conclude the question part of the panel here. And I wanted to kind of continue with the theme that, Bob, you brought up earlier, the Polynesians. I thought that was excellent. So one summary theme that I like to present before I turn it over to Ron and Hirokazu is regarding the space industry in general, and the new space industry in general that we've talked about thus far. So the new space industry is just like any other industry that has gone through growing pains. So as you can imagine, like any other industry, companies will make it big in new space. You'll hear about them every day. They'll make the front page news. But there'll also be companies that will fail miserably and blow up. None of these, of course, but others may do that. And then there'll also be companies that you won't hear about at all, but will perform kind of an essential role in the backgrounds of the space industry. So this is true amongst pretty much every industry out there. Space is no different. But one unique factor that space has is that space itself is inherently cool. It kind of, it caters to that internal burning desire of every human to peer beyond the horizon, to venture out beyond the known to the unknown, to explore, to ponder, to pontificate. Space is that industry. At least I would believe it's so. So much like the Polynesians when they ventured out into the large, vast emptiness of the Pacific and discovered new areas, much like the indigenous of the North and South America that walked for thousands of miles without any destination in mind, much like our early ancestors who went out of Africa, or even Leif Erikson and Columbus. This inherent human desire is not going to end. It's not going to go anywhere. It's part of our DNA. That's not going to change anytime soon. So in the future, as we progress in the space industry, this burning desire will be one of the catalysts that kind of progresses the space industry forward. And it's definitely going to be one hell of a ride. So thank you. Let me turn it over to Ron and Hirokazu.